In this video, I'm going to show you how to create a data model using WhereScape 3D within a CI/CD workflow. If you're a data modeler or data engineer and you're looking to create data models effectively and accurately within a modern CI/CD workflow, using a tool that helps you focus on the problem and the modeling rather than spending all your time debugging code. So we're going to head over to the computer where I'm going to show you how I use WhereScape 3D to model data from a source system all the way through to creating a star schema with all the corresponding tables to support the data model. I'm going to show you how I commit to Git on an individual basis as I iterate through the design, as well as doing a commit that pushes the entire repository and all objects back to Git. What I want to do now, I've established that I've got all of the data I need. I've found pretty much the fact data that's needed in the order line. I can see that it links out to employee where I have information about the first name, last name. I've got some HR looking data in there. I've got current position, which is good. And then I've got customer code, shipping address. I've got all the information I probably need there. I can move on and start to build out a star schema. So we're going to go through a star schema, but of course we could also create a data vault and go down a raw vault or business vault process. So from here, hit commit to Git. And I'm going to commit the changes back to Git. I now want to build a star schema. So I'm going to create the workflow, click on the workflow star schema. I'm going to create a new one called sales, and I'm going to call this main. You'll notice that I've kept the version number main because this is the main version of development, and this helps me maintain a consistent model version file that I push in and pull out of Git. I can start working through the candidates for my design. So core concept design. I want to incorporate customer, employee, order header, the order line, the product, and that covers everything in my use cases. Salesperson is the employee, customer, product, order, date. Well, we don't have a date dimension in here, but we can handle that later. We click on finish. So now we have the first start of our star schema, and here I can say initial build for the sales star schema. As before, the commit and all of the issues have been linked as part of the commit message, helping me keep track of progress on my user stories. So now I want to go through the process of starting to build out my fact table. So rather than you sitting here watch me play, I'm going to go ahead and make the changes off screen. So now I've redesigned the initial design that I incorporated from my source model, and I have now got my customer dimension, and if you look at the source mapping, it's being routed from the customer table in my source system. I have my products table, and I've added a few more fields in here to group and bring in the groups, the product lines and the subgroups. Also my fact table where I'm grabbing the information from several places, but primarily from the order header and the order line. Entities themselves don't have any connections between themselves because that is being held in the source model and will be used in the next step when we start to build out our physical objects that we're going to need to support this data model. You can also see that we have all the relationships between the fact tables and dimension tables that highlight synthetic keys that we'll create to control the records between the fact tables and the dimension tables, as well as any existing relationships that were there as part of the underlying source system. So now I've made that change, I'm going to hit commit to Git and send that into my Git repository. So now the next thing we want to do is we want to create load and stage tables that will support this set of data tables as we move through and get closer to being able to physicalize the tables. So the workflow from here is to create load and stage, and from here we'll create a new model and we'll call it sales and we'll call it main to keep the model name versions consistent throughout. We're going to use the original source mapping, and we're going to apply the magical model conversion rules, and we're going to apply the model conversion rules to help automate the build of the data model. So So if I now open up, you can see now we have the design here. We have our fact and dimension tables, we have the stage tables, and we have the load tables. So the load tables will hold any relationships at a first level and will be used to replicate the data from the source system into the data warehouse. And then we have the stage tables that will be populated by the load tables, and that will be there before it populates the dimensions and facts. Looking over this, it all looks pretty good. There's not much I want to change, so the next thing I'm going to do is commit this to Git to save the model version. Now at this point I may have a need to start creating where I store the data inside of my final target platform. So I may want to store the dimensions and facts against or within schemas or different databases, different platforms, and we do this using target storage locations. And I'm going to create a target called load, and I'm going to push that into Snowflake. I'm going to create a target called stage. I'm going to create a target called star, and this is going to be used to store different objects that I may want to apply. Now that we've created our target storage locations, we want to get this ready to physicalize the data model and push it into our target platform, which in this case will be Snowflake. So we use the workflow button to prepare for red, and we are going to do sales, and we're going to go to main and create a model version again, which is consistent. I'm going to use the RDBMS for the specified location, and here I get the chance to pick everything and move all of these into a certain target. So anything that is my dimensions and facts are going to be moved into star, anything that's load is going to get moved into load, and anything that's stage is going to be moved into stage. So you can build automations to control this for you, but you also have the ability to manually overwrite. And I click on next. I don't have any groups, but I can group the objects up. If I'm working on more than one data model, that's a useful way of segregating everything. And then from here, I'm going to trace where the data comes from. So it's going to be Snowflake, and click on next. And as you can see, it's mapping all the SQL data types into Snowflake data types. Now I can display the data model that's been created. You can see all my load tables, all my stage tables, all of my fact and dimensions all set up, ready for us to push into Git. All the way through this, we've committed per change on per model. The other options we do have is to commit everything to Git. So I'm going to use the commit all objects to Git, and this will force everything out of WhereScape and move it into the Git repository before sending it over to the remote Git repository. So at this point, all of the configuration, all of the changes has been committed to our Git repository, and if I refresh, I can see that the commits just happened, and if I click on that, I can see all of the objects that were detected to be different based on the previous commit. So let's say we have a model version in the source category we want to bring back. We can use the import from Git function, and that will enable us to assess how many versions of a model there is, and we can bring it back from a selected branch. So if we pick the development branch, because at this point that's the only branch we've been working through, we can then select the sales model, but it will tell you any model that's existed in time within the Git audit. You can then pick the main branch or the main model version, and then from there it will list back all the various details and options of change that you've had. And here you can then start to decide whether you want to overwrite the existing model or if you want to bring it back as a different model version with the commit version within its name. So we're going to go with that to create a second model version. You can see behind the scenes we have a new model version within source, And if I right mouse button and display that, it will show us a previous change. And from here we can commit this back up as a separate model. We can use WhereScape's functionality to merge models into another source, so you can merge this into that and then figure out the differences, or you can just use it for reference and discard it without sending it back to Git. So let's go through the process of sending it to Git by hitting commit to Git, so we can demonstrate the other option we have for deleting a model. So that model is now being committed to Git, and if we head over there we can see cool, and there you can see that's the latest commit where the brand new model version has been incorporated. So if I go back to my WhereScape, I can go and select the model version that we've just created and use delete model and commit. And what this will do is it will remove the model from the repository, so it cleans up your 3D repository, keeps it nice and nimble. So that's now done. If I head over to my repository, I can now see the latest commits, and if I go into that you can see the model's been deleted. As you've seen, I've quickly built a star schema data model within WhereScape and committed all of my changes back to Git. WhereScape 3D's automation enables me to focus in on the data modeling and quickly build out the objects needed to support the data model. Git helps me have a full audit history of all of the changes made to that data model and at which point in time, enabling me to see who changed what and when. That gives me ability to scale out my data team, either scaling up or down to better accommodate any requirements that come from the business. Using GitHub, I can now build automation over the data model design, so I can start to peer review the design during the design process rather than waiting to the end. This helps me avoid failure. Having all the audit history stored in GitHub gives me the chance to roll back and undo any changes that might cause problems down the way. In the next video, I will show you how to improve your workflow by creating branches and merging branches.